Okay, the first thing we're going to talk about is complex numbers this week. Complex numbers it's a set of numbers bigger than the real numbers. All right, so where do they come from? Well, if we tried to solve the equation x squared equals -1, how would we do it? Well, some of you might want to think, hey, we can square root both sides. And that's fine, let's do it. If I square root both sides, what's the square root of -1? If you plug it in your calculator, what's your calculator going to say if you try to compute the square root of -1? Well, it's going to tell you have an error. All right, and so we actually try to extend the real numbers to include such numbers as the square root of -1. The only difference is we don't go around saying square root of -1, square root of -1. We substitute it with the letter I. All right, and we actually refer to I as a number, and again, it designates the square root of -1. And one other property you guys need to keep in mind is that the square root of -1, yes, that's the letter I, but keep in mind I squared equals -1. This is key for the remainder of the lesson. All right? And so when we think about I as the square root of -1, we want to refer to I as the imaginary unit. It's something that the real numbers don't have. All right, so a complex number is in the form a plus bi, and we'll typically refer to this as standard form. All right, and we'll refer to a as the real part, because if we didn't have this bi, then it's just a real number to us. Once we add on, or of course we can subtract the bi, that's what we call the imaginary part. It's what makes this a non-real complex number. All right. Now let's just run through 3 cases. All right. So first we could have a equals 0. All right, and b is non-zero, which means we just have something like 2i. Another example here would be 7i. All right. Another example would be pi I. All right, and these are pure imaginary numbers. We could also have a situation where neither a or b are 0. They're actual numbers to us, in which case we have 7 plus 2i, 14 plus 3i, where we have a real part and an imaginary part. And we call these non-real complex numbers. And then lastly, we could have a situation where a is non-zero and b equals 0. In this situation, the complex number is just a real number. All right, so again, there is no bi. All we have is some real number like 2 or pi, or the square root of 2. All right, and this is just a little picture for you guys to see where, look at the green, the real numbers, and how they sit inside the complex numbers. All right. All right, so one last thing we want to talk about here. When are 2 complex numbers equal? 2 complex numbers are equal if the real parts are equal, so a equals c, and the imaginary parts are equal, so b equals d. And this is the only situation where 2 complex numbers are going to be equal. All right, and just to clarify, I want to start telling you guys what you need to get out of all this. All right, so before exam 1, what do we want to get out of this lesson? Make sure you guys can add, subtract, and multiply complex numbers. You want to be able to find the conjugate of a complex number, so after we go through division, that should be very easy to do. Of course, then we want to be able to divide complex numbers. We want to be able to add and subtract and multiply negative radicands. So this is when we have a negative number under the radical. And then we want to be able to write negative radicands in standard form. And again, that standard form is just a plus bi. So I'll go through, talk a little bit about this stuff, and give you guys an example.